Hi, I'm Yutong. Welcome to ITS TechFest2020 XR project demo section. Our team believes in fun learning. Today I'm going to answer 3 questions: how we work, what we do with reality, and who are engaged in our team. I want to draw a simple flowchart to make things clear. First, our goal is to build a cross-platform space aligned with your learning objects. Second, apply your assessments to track students' learning outcomes. Finally, we want to, together with you, conduct educational research by providing you data mining tools, Blackboard reports, and algorithm solutions. There are 2 ways we structured our reality. One, we call it a 360 world. Another, we call it the artificial world. 360 world, we call it nowadays world. So far, we made 9 360 projects through 3D Vista. Here, I will show you the top 3 highlights of a kinesiology department tour. By clicking Dr. Mandy, you can watch her and listen to her.
Hi students, I'm Dr. Mandy Ram, and I would like to welcome you to CSUSB's kinesiology department.
Here, you can list all your multimedia resources in the tour. Students can walk through the building or view the floor plan to locate themselves. If you want to learn more about the 360 virtual tour, simply email me here. By using Unity Engine, our goal is to create an imaginary learning simulator to help students memorizing terminologies, apply functions, display their fine arts, or just trick their brain to think out of the box. For example, during the summer, we help FMA students to create virtual data to express their creations in a safe way from COVID. The students can play on their computer, tablets, or smartphone by using our AR app, landing the data in their bedroom and use your fingers to find the details.
The project I'm working on right now is a conceptual piece playing with inherited trauma and family tree. So I'm putting together a scan of my legs, life-size, with a found tree trunk. Finding ATI was so serendipitous. Everyone I've worked with in the department at ATI has been super supportive. It's magic to work with that kind of collaboration and that team.
Presently, my team has Bobby, Alex, Kim, Noah, GC, and Lloydie. Welcome to join us. You will see their talents right now.
I've been in charge of creating what the museum actually looks like. That goes from the assets as far as the art pieces to something as simple as a wall plug. My process of doing this is basically I start by texturing off, then I create that, and once I have the model, I apply all that stuff to there, and I put the pieces together, and we get a visual representation of what is what. It's really fun, and if anyone's looking into that, I highly recommend that.
With photogrammetry, you can take a bunch of images of an object or an area and convert it into a 3D model that can be placed in your environment. I work with 3D Zephyr and Reality 3D. With 3D Zephyr, I reconstructed this art piece of wooden legs. In the high-definition model, you can hardly see the difference between the images and the model. These softwares work great for capturing opaque, non-shiny objects, but not for translucent or transparent materials. Here, you can see the pill bottles on the left and one of the reconstruction attempts on the right. For objects like this, it would be better just to have our 3D modeling expert, JC, just create them. Here's some other objects that were created by the software to show you its capability.
We are making this experience within the Unity game engine and are exploring different approaches to make sure that the art is well represented in this virtual environment. My main focus for this project has been to build a solid foundation of code that can be quickly expanded upon as we acquire new assets from the artists on campus. Some of the current interactions included in the project involve orbiting art pieces, a gallery viewer in which players can scroll through images, art pieces with audio files attached to them, as well as a fully functioning YouTube video player. Currently, we are using this video player to give an introduction of the artist and their project. There are many ways to interact with an object, which is why being able to customize each interaction is very helpful. Some examples of interactions that can be recreated within Unity are measuring 3D models, using physics to move objects or pick them up, and having UI buttons to trigger certain events, just to name a few.
What's so interesting is that using Mars made it much easier to develop an application for augmented reality. So for example, for the MFA project, I was able to detect when you're trying to get the room on the floor or on a table, so that way you could somewhat scale to an appropriate size for the project. So for example, on a table it would be scaled smaller. But using Mars, you can do actually a lot more. So for example, you could detect walls, or you could detect faces, or even images. So if you had like a printed out picture of, say, an apple and scanned it with an application, you could see a 3D application over the apple if you wanted to.
Using 3D Vista, faculty can create virtual tours for students to explore. Embedded content such as videos, audio clips, web pages, documents, and more offer different learning functionalities, while assessments like quizzes allow students to demonstrate their knowledge based on predetermined learning objectives created by faculty. Both students and faculty have an amazing tool with virtual learning environments to explore course material in exciting fashions.
Recently, I've been working with the programmers on implementing breadcrumbs on how to be informed of the art pieces in the museum game. And on the side, I've been learning Unity's new UI engine and programming language that will be coming out next year.
If you have ideas or you want to play with us, please contact us right now. Let's build a fun space for our learner and engage them with their preferred media. Thank you for watching.